to produce the topographic map. And basically, there are the authorized, the stakeholders who provide those topographic data. But as a surveyor, usually the topographic data been the job of producing or getting the information for the topographic data been sub to the licensed surveyors and all these authorized surveyors for the data collection purposes. Okay, then they need to design the map and submit to JUPERM for the agency to endorse the topographic map. Okay, but in the other hand, about the thematic mapping, okay, is a really wide, it's a really general topic. It really depends on what the purpose of you presenting your map. So previous lecture we have discussed a lot about the 5 main issues, which is the message. Okay, as we communicating with other people. Okay, as the cartographer communicating with the users. Okay, so in the communication there must be something to what is the topic, what is the title or the message that they're going to deliver through the communication. So that is why, as a mapping, the map is the medium for the communication between the cartographer or the map maker to with the users. Okay, so as I mentioned, the message. What is the message they try to convey from the model? Okay, who is the audience? Basically, we can say that as a targeted user who going to use your map. Okay, some of the map be used by a general people. Okay, but some of the map are using specifically for a certain group of people. Okay, so the audience or the targeted user need to be identified while you designing your map. Okay, and about the medium as a platform. Okay, for example, when you are communicating, the cartographer try to communicate with the user. What is this medium? Either you are using the hard copy map, analog kind of map, or either they are using the digital medium for disseminating the map. Okay, so analog and digital both have the pro and con. They have a certain constraint. Paper size, for example, is the big constraint when you're talking about printing your map on the paper. Okay, while when you are discussing to use the digital platform as a medium for the disseminating the information. So in the digital environment, they also have some constraint, for example, like the physical size of the map. Okay, and also about the screen that your user will use to view your map. Okay, because we have no control on the screen size toward the end of the users. Okay, so certain constraints have been discussed also in last week. I'm not going to tell that more on this week. Okay, rule of aesthetic that they follow the cartographic rules. For example, I always mention that the blue color is associated with the water bodies. Okay, the green color associated with the vegetation and so on. Okay, and also for the labeling using the text. Okay, for water bodies also they are using the cyan color or the blue color to label the water features. Okay, as the very simple example, I shared to you the Atlas map. If you still remember the map with a Malaysia map in Atlas form. Okay, with the blue color for the water bodies, the Malaysia being highlighted with the bright color, and the non-important features, for example, like the neighboring country using the dim color, and you see also how they use the labeling color, font, bold, italic for a certain naming the features. Okay, so there's the rule of ethics. We can discuss about this on the visual variables after this, and for the technique is how you're going to present your data. Either your map will be the animation map, or the map will be the static map, or your map will be the dynamic map where the data are changing throughout the time. For example, if you go to meteorology or weather forecasting website, they will update the data, might be every minutes or every hours. Okay, so it's displaying the information dynamically based on the data that they have, and some of them call it as a real-time mapping. Okay, so what is the technique that you're going to use is the fifth issue that need to consider while you designing the map. Okay, so that already been discussed in previous lecture. Okay, for today, I'm going to go fast with this because they have been mentioned in our briefing. Okay, the model, as we mentioned, map is our model to represent our real world. Okay, so the representation of certain object or figure in the real world can be represented by a model. So in our case, a model is a map. Okay, representation should be able to show what really happened in the real world. Okay, what really happened. So if you are talking about getting information of topographic map, you have to taking in detail what really happened. Okay, either in the invert level of the drainage. Okay, the height of a certain building. Okay, it should be representing what really happened in the real world. Okay, many research being done using representation model to see the different scenario. Okay, the questions such as what if should be able be answered with the model representation. Okay, for example, of flood modeling. Okay, we model the flood and we can do kind of prediction. Okay, for example, if the rainfall did not stop for 4 days with the kind of certain volume, so from the model we should able to estimate or to predict which part of the area will be flooded. Okay, depending also on the soil content, depending also on the river water level, and so on. Okay, so in order to create or to design a flood modeling, we need to use a multi kind of data sources. Okay, so this is why we create a model. We not just to capture the information and map it as data. Okay, so the question nowadays is what we can do with the data now. Okay, other than we only having the data, but we did not make fully utilize of those data. So nowadays it's time for the people, for the surveyors itself. It's not only acquire the data, but they have to think what the data can be used for. Okay, so usually it be used on a certain application. Okay, for example, as a flood modeling. Okay, for the model, also model can be designed by different form. For example, in 2D model, okay, in 3D model, okay. For example, in 2D model for a map, for example, a drawing, for example, is kind of model. Okay, contoh, for example, like a portrait of Mona Lisa. Okay, even though it is the drawing, but it's a 2D drawing to model how Mona Lisa look like. Okay, so it also kind of model. Okay, and beside the 2D model, we also have a 3D model where the 3D model can be used to represent the real world in a better form, clear, near to the current or the real situation in the world. Okay, so for example, a doll, okay, a doll, siapa-siapa yang dulu kecil-kecil suka main Marvel, beli patung Ultraman lah, beli patung Superman dan sebagainya. So it's a doll. It also is a model to represent the person or the superhero that been shown in the movie. Okay, human also being used as a model, and also the map as user model. So we have discussed this, and why we are using model. Why are you using picture? Because a picture can tell thousands of words. Okay. For example, for those who from the second year, for the third year, when you come first to UTM at the early years ago, it's hard to go from one location to another location. Okay. For example, those who want to buy some goods, some grocery, usually they will go to Aeon or to the Dasco in Taman University. Aeon, nowadays they call it as Aeon. You can ask the people how to go there. Okay, so the people or the park guard, the safety officer will tell you how you can arrive to the Aeon. Okay, by using verbal, of course, and you try to understand. And unfortunately, bila kita jalan, we go through, and sometimes kita been our focus been divert to certain other things, then we start to forget. Ini depannya belok kiri ke nak belok kanan? We need to turn right or turn left. Okay, so when we have the picture, when we have the model, even though in a drawing form, it's easier for you to understand one, and second thing is easy for you to memorize. Okay, so the pictures can tell thousands of words. It can show you the relationship. Okay, after the guardhouse, you will see this a deer farm on the left. Okay, and then the guard post, and then furthermore, you are going to have a left junction. Go to JB, don't take left. Go forward further, and you're going to see another traffic light. Okay, if we are communicating through verbal, yes, you can understand, but it's easier if we have kind of drawing, and easier for you to remember. Okay, so this is one of the reasons why we are using map to representing the real world. Okay, this is another example. Okay, about the discussion is an illustration of cartoon. Okay, so you can see that on managing, administrating our countries, we have to get kind of a model so we can do a discussion and making decision on having this information of our location, our space, okay, our countries. Okay? But using 3D is a much better, okay, because as you know, we are living in a 3D world. We occupy not only a location X, Y, but also the Z. So the Z value is another dimension for us to model. Okay, so lagi mudah, is easier for us to memorize, to understand the situation in the 3D form. Okay, for example, in Malaysia, one utama for those who come from Klang Valley, I think they are familiar with this shopping mall. They call it as a One Utama shopping mall, located at the Damansara. Okay, you can see on your top left image, this I change this to point. Okay, you see this image. This is previous One Utama. They only open at this right wings of One Utama. After certain years doing good business, they managed to purchase a land over on the left side, and they connect these two land with the bridge, is something like that on the right side. Okay, the bridge connecting these two building, but underneath it is the common property which belong to our local government, which is the road. Okay, so this situation, which is involved definitely in 3D environment, but somehow in Malaysia we have problem to register this ownership, the on-bridge ownership, because our Strata Land Act give the right to the ownership not only on the property, but also on the ground. Okay, so because previously this thing had not been imagined that we're going to have this kind of building. So the Land Act is been designed for the previous situation, but in the rapid development of the buildings design and so on, so this thing happened. Okay, so in our normal cadastre in Malaysia, they don't have any act to register this ownership. Only they can provide as a using the air right untuk 21 tahun. Okay, for 21 years. So there's a use the air right permit, okay, for that. Okay, but somehow, as I mentioned, we need to have the 3D data or 3D model in order to represent our real world. Okay, and also at the Plaza Putra, where the Dataran Merdeka, in the Merdeka Square, underneath the Merdeka Square, there are a lot of shop before this. Even they have a shopping mall, even they have the cinema under the square, but somehow it's not being used anymore. Okay, it's not being used anymore because why? Because that area or that property cannot be transferred to individual. It still belong to the BGL. Because why? Because of our Land Act did not allow us to model it in a 3D. Okay, so because of that, that area not in good condition currently. Okay, and furthermore, you can see this KLCC. I think familiar to all of you. Okay, where is a multi-level of development. Okay, in the top building is this 2 tower, consists the office building, underneath is shopping mall, and also the car park, and also the recreation area, and so on. Okay, so multi-level. So how we can model this situation only if we rely on the 2D model. So it shows that the 3D model is crucial ataupun is essential for us to have in order to model our real world. Okay, so for example, as a back to the basic in mapping, we use the point, line, and polygon as the representation. Okay, for example, this is the cadastral data. Okay, we know that cadastral data is the data to show the properties of certain piece of land. Okay, where is bound with the accurately surveyed boundaries. Okay, so from in order to get or to keep the information of certain piece of land, they will use point as the boundary marks. Okay, basically as a boundary stone. Usually they on survey they use this stone for getting the datum. Okay, but actually this boundary marks is purposely being plan into the area for the boundary marking. Okay, and connecting the two marks will have the line, the boundary line, and with the connecting all those boundary line with the closed loop, it will be a polygon. So that area is a piece of land belong to Encik Ahmad, Encik Abu, or Encik Ali. Okay, but in order to map or to model that piece of land, they are using the point as a boundary marks. They're using the line for the boundary line and also the polygon for the area. Okay, so this is the basic features that we use in order to model or to do the mapping. Okay, so this is kind of simple data to represent or to be disseminated to the users the information of cadastral data. Okay, the next one, what is this? Who can guess?
Contour.
Well, okay, because you already have this kind of connective information, you are used to this line, and we can say that yeah, this is contour. And what is contour for? To represent what?
Elevation.
The elevation of the ground. Okay, so in the same line we represent the same height. Okay, for example, there's a contour interval of 20. So the same line. Okay, for example, this line will be considered as the same height of 20 meters. Okay, so how the contour works. Okay, so they tell the users the ground level, and from the contour itself, you can see that some of the line are close to each other and some of the line are far away from each other. That will show that how steep is the slope. Okay, the nearest, the more dense contour line, it will show that the steepness of the slope. Okay, so I would like to ask you guys, from this contour, which is the higher ground or which is the lower ground?
Cannot be decided, Doctor.
Why?
Dia tak tunjuk pun nilai elevation.
Yeah, because they shows the contour interval, right? Usually in mapping, in topography map, they will show the numbers on the line saying that this is the contour. Okay, and this is the line that representing that certain height. So from that we can identify which is the higher ground or which is the lower ground. So for this we cannot tell, but usually in mapping, in the current mapping system, they will keep the information of height in a table form, okay, where each line basically have the information of the height, but this does not appear on the map, okay. So if I show you this map, another map, okay, from this is also the representation on representing the height, okay, using the colors and so on. So from this image, can you tell which is the higher ground or lower ground?
Cannot.
Cannot? Can you guess?
Sebab tak ada legend.
Tak ada legend, exactly. Betul. Tetapi kalau you boleh agak-agak,
putih tu could be the
Biasa makin gelap, makin tinggi.
makin gelap makin tinggi. Yang putih tadi apa Sawan cakap tadi?
mungkin lebih cerah, lebih tinggi, lebih gelap, lebih dalam, lebih rendah.
Okay. So ada kontradik lah. Yang tadi seorang tu kata yang gelap tu value lebih tinggi, yang putih, yang cerah tu value yang lebih rendah. So you are referring to this cartographic rules, the rules of aesthetic, saying that the darker color should represent the higher value compared to the lighter color that will represent the lower value, right? Okay, saya setuju dengan awak. Yang putih tadi kata tinggi dan yang hijau tu gelap. The white color is higher ground and the darker green is lower ground. Can you tell me why?
Sebab lagi dalam, lagi kurang cahaya matahari sampai.
Okay, so that is a good answer, kurang tepat. Okay, tetapi what siapa tadi jawab tadi?
Saya Dr. Najwan.
Najwan, okay. Okay, so sebenarnya actually this color being used widely by the geography people, okay, showing that the white color is the higher ground and the darker green is the lower ground, okay, even though it contradict with the cartography rules, okay, but somehow what they did is they try to represent the real world. Okay, kenapa? Okay, if you remember, while you are still in a early age, okay, you draw a mountain, usually dekat atas gunung ada apa?
Ada ice.
Ada salji, ada snow kan? Usually bila kita masa kecil-kecil dulu ataupun masa dah besar-besar ni pun, when we draw a mountain, usually we know that in a K2 mountain, in Gunung Everest, even in Gunung Kinabalu, di puncaknya adalah is a cold area, okay, because it's a high ground, so sangat sejuk. Sampai even though kalau kata yang the tall mountain like Everest K2, they covered with snow. Okay, so in that case, they are using the white color to represent the top or the highest value for mountain, for DTM, okay? And you can see furthermore, biasanya toward lower area akan ada a small tree, a bare land, a small tree, until bila dia sampai bawah certain lower ground, they see a very thick forest, okay? Pokok yang besar-besar yang dan sebagainya. So they color it with the darker green. Okay, and if we have more variation of data toward the end, the lowest ground, they will use a cyan color showing that arrive or achieving the water level. Okay, so even though this map did not apply the rules of value or darker with a higher value, lighter with a low value, okay, but it represents how it look like in the real world. Okay, so with that, some of you will get the impression of the white color is the higher ground compared to the darker green. Okay. Okay. So another image, the same data. I derive this data from a spot height. Okay, from the spot height, I create the contour at the first, and then I create this called as a digital elevation model. Okay, for this entire area. And this one, I use also the spot height to create, they call it as a thin triangulated irregulation network, where each point are connecting in a triangle. So you can see the small triangle within the model. And from this model, even it display on the 2D surface, but the user can get a better impression of high value. Okay, so from here, you guys are easily to say that the white color is the highest value compared to the darker green area. Okay, and even though if you look into this, the center of this mountain, they kind of a kawah, a kind of kawah di atasnya. Okay, so this is another technique of representation. Okay, the same data, you derive it from the spot height. Okay, but a different way of representing the height data. Okay, so this using the triangulation irrigation network, which is thin, and we can see it more realistic as a 3D model, even though it's still been displayed in a 2D surface. Okay, what they use here is the lighting effect. Okay, you can see the lighting effect from the top left, and on the bottom right, you can see the shadow. Okay, if we can adjust the light source and put it from the bottom left, this image will be seen as a canyon. It's not as a mountain, but as a canyon, lembah. Okay, so it's only play with the lighting. So that's why I'm mentioning in cartography, we involved with the science, art, science, and technology. We are playing with the arts and also the science on displaying the data, and also the technology that we use. And furthermore, you can see on the last image over your bottom right image is the image that derived in the thin and being viewed in a 3D viewer. Okay, at this part we can move, we can turn, we can rotate the image, even though we can see the image from underneath. Okay, so it depends how we present the data. Okay, if you ask me where we got the data being derived from the spot height. Okay, so from the spot height, it depends on us how we going to represent the information. Okay, so this is a simple spot height as a 3D data. Macam mana, how we going to represent it in a 2D platform. Okay, kita boleh gunakan the contour, kita boleh gunakan the color, kita boleh gunakan the thin, kita boleh gunakan the 3D viewer in order to present the information of the DTM, digital terrain model. Okay. Some of them call it as a DEM, some of them call it as a DTM, some of them call it as a DSM. Okay, so basically there's not same between each other. Okay, DEM basically is more general term using the digital elevation model. Okay, even though elevation sound like height, but elevation can also represent a different data. Okay, for example, like if we are talking about the state of Johor with the different districts, okay, and the Z value, instead of using the height we can apply to the different data, such as the population. Okay, so which district that have greater population will have this a certain height. Okay, lower population we have a certain lower height of the elevation. So the elevation basically they are representing the population, not the height as we always use as the third dimension. Okay, so DEM is general, but we're talking about DTM. We are referring straight to the terrain. So when we're talking about terrain, without a tree, without the building, okay, only the terrain. Okay, but we are talking about DSM, which is the digital surface model. Digital surface model will include the features on the ground, such as the tree, such as the building, and so on. So that we call it as a digital surface model. When talking about DTM, refer to the ground, we should use the term of digital terrain model. Okay, DEM is quite general. Okay, referring to what is the data that been placed as the third dimension. Okay, so this is one of the way to represent the 3D information or 3D data on the map. Okay, and you can see, for example, this building. Okay, definitely in a 3D form, and normally we present it only in 2D, but somehow, as I mentioned, 3D representation are needed, so we can present the data into a 3D model. So from here is better for the visualization and better understanding how the situation, how the environment look like at that particular housing area. Okay, so as a cartographer, when you try to create a map, ask yourself, how do I say what to whom? Okay, if you reflect to the issues that we need to be considered while displaying or while you presenting your information, and which is the messages, refer to what we want to tell, what is the message, how is the technique, the medium, how do I see the design part, and to whom is the targeted user. Okay, so whenever you consider to produce a map, remember that 5 issues and ask yourself, how do I say what to whom? Okay, it will trigger who is your user, what is the data that you're going to deliver, the technique and the medium that you're going to use in disseminating your information. Okay, so why map? As I mentioned just now, why map? Because map can tell thousands of words, as I mentioned tadi. Okay, map should offer a solution to question like, where can I find? Okay, how do I get to? Okay, it's question that related to a location, then the map will play the role on delivering the information. Okay, what is this feature at? What else do I find? Where else do I find that features? Okay, for example, some of you come to Johor and try to find a shop, for example. Okay, nak cari satu kedai makan tom yum sedap dekat JB, a good restaurant for tom yum. Okay, where can I find the good tom yum stall? Okay, how can I go there from UTM to that stall? Okay, what is the feature at? Okay, what else is available on that area? Okay, what else do I find that features? Where else do I find? So beside that tom yum, where is other shop that I can go for another option? Okay, so this question is related to geographic question. So that's why in this matter, map is the best way in order to disseminate or to represent the information. Okay, that's why nowadays they are using the Google Map, you're using the Waze for you to navigate from a certain location to a certain destination. Okay, dissemination of the information is more effective as I mentioned just now, easier to understand. Okay, macam tadi saya dah bagi contoh, the example that you ask for people how to go to Jasco Taman University or Aeon Taman University. Okay, easier for you to understand, easier for you to remember compared to verbally information. Okay, buatnya kita jalan-jalan, depan tu kena segang dengan pagat, mana kat metrik tak bawa, kita dah terus tergabra, lupa, lepas tu nak belok kiri, belok kanan, kita tak ingat. Okay, so when it involve verbally, it's hard for us to remember. Easy for us to forget. Okay, that's why it's good to represent it in a map. Okay, best way to present certain object or phenomena that consists geographic or spatial information. Okay, now we come to the map elements. Okay, I saw I have glanced through some of your submission in your lab 2. Okay, some of you just you maybe don't have the experience of designing a map or using a map, but actually we have discussed it in the early part of our lecture. Okay, the map elements, the title of the map is very important. Okay, this title will bring or will set the knowledge of the user to that particular issues. Okay, if you provide a map telling the users about the situation of COVID-19 in Malaysia, for example. Okay, so when the user read the title, they will set their mind to get information about COVID-19 in Johor. So when they look at your representation, your information, it make them easy to digest and easy to understand, because why? The mind already set about what they will receive, what will they see in the map. So that is the importance of title. Okay, so some of you submit the map without a title. So apa? So I give you kind of example in our previous lecture. The map without a title, in yellow color and in red color. Okay, so what you feel when you don't have a title for the map? Okay, we are start to guessing, what is this map all about? This boundary is showing what? This color, different color showing, representing what information? Okay, so that's why the title is the very important element. Whenever you create a map, please put a title. What is title? COVID-19, kawasan Johor, for a date of maybe in January to May 2021, or from the last year for the start of PKP. Okay, so the title is very important to be mentioned in your map. Okay, the scale, as we discussed also before this, the scale is also important. Okay, for the user to estimate distance or the area of that particular model. All right. The frame is another map element to make the map look nice. Okay, some of you submit your AutoCAD without the frame, so it's kind of floating here and there. Okay, so it's not good design, but we might find a map without a frame, but that will be a thematic mapping, not a normal map without the frame. You need to play around with the design. Okay, I will show you some example after this. Okay, and a legend is very important. Okay, whenever you draw a map, the green color should represent a vegetation, but anyhow, the legend should tell the users this green color is for vegetation area. Okay, this blue color, even though in the cartographic rules, cyan color is for the river of water bodies, but we still need to mention it in a legend. Okay, so the legend is another map element that is very important. The north arrow can be designed as what the designer prefer. Okay, the purpose is to show you the direction. Okay, usually when people use the map, they will see where is the direction. Okay, otherwise with the loss of orientation, and then it's hard for us to understand the map and try to understand the real world. So The north arrow is another map element need to be placed in your map. Okay, the grid also is another map element. Okay, to find out where is the certain location. Okay, in which grid for easier for the user to find a certain object. Okay, and what else? What else? Apa siapa yang biasa guna map? Apa lagi selalunya dimasukkan dalam satu map? What else? The elements or the site information that be embedded in the map.
Peta kunci, maybe.
The key map, yeah, the location map. Sometimes they call it as a peta kunci key map. Sometimes they call it as a location map. Okay, for example, you are mapping the state of Johor, and there will be a peta kunci ataupun a key map showing that Johor is located at the southern part of Peninsular Malaysia, right? So the key map is another map elements. Some more?
Created date.
Apa dia?
Date.
Date. Okay, the date. Yeah, the information. When is the map being produced? Okay, when talking about the date when it been produced is very important also. Okay, for example, we are using the topographic map that been produced in 2012. Okay, this map been produced in 2012 is still valid. Is it can be used in 2021? Okay, so the date of producing the map also important. Okay, and beside the date, of course, who is the producer? Who draw the map? Okay, the map being prepared by certain company, a certain person. Who authorized the map? Okay, the licensed surveyors or what? Who endorsed the map? Okay, it's another issue, another information that need to be applied. And lain-lain. Coordinate, very good, Nur Arisana. Siapa nama itu tadi? Nur Arisahanani. Okay. So coordinate system, the map projection that we use. Okay, sebabnya because the map could be the data input for another map. Okay, so in order to use another data, we need to identify what is the map projection, what is the coordinate system that they use for the map. Okay. And for the scale, just now kita ada mention juga pasal scale. Kalau kata kita ada data, a very large scale of data to map Johor Bahru, for example. But when we have the data of coastal line in a small scale map, so it will disturb or it will affect the accuracy of those data. Okay, so scale also important. It's not only for producing a map, but to identify the quality of your data input. Okay, we're going to discuss after this about the scale. Okay, exactly the coordinate projection, the coordinate system, who do the map, date, and so on. Okay, the scale. Okay, ratio. The scale, okay, this is what I've been discussed in our lab 1. Okay, the scale is a ratio between a distance on map and the same distance on the real world. It's straightforward. 10 cm in a map, you multiply with the scale, and you will got the same distance on the real world. So that is the scale. Okay, so how we tell the users about the scale? Okay, the scale type that we use. Okay, so for example, 1 to 5,000 considered as a large scale. Okay, where 1 centimeter in the map is equivalent to 50 meter in the real world, while 1 to 100,000 considered as a small scale map, where 1 cm will consider the same as a 1 kilometer on the real world. So the large scale map, small scale map, okay, it been defined by the scale that they use. So how to represent the scale? There's several types to represent the scale. First is by sentence. Okay, sometimes when you use the old map, sometimes when you use a topographic map, they still use this type of a scale. Okay, for example, 1 centimeter equivalent to 1 kilometer, even they use a different unit. Okay, 1 centimeter equivalent to 1 kilometer. So whenever you measure that 1 cm on the map, it's equivalent to 1 kilometer. So this rarely be used, but you still might we find these ways of telling the scale. And usually the ratio type is commonly being used for mapping. Okay, for example, like 1 to 100,000, 1 to 5,000, 1 to 25,000. This called as a ratio scale. Okay, it will represent in the same unit. This means that when you measure 1 mm is equivalent to 100 mm in the real world. Okay, if you measure on the map is 1 cm is equivalent to 100,000 cm in the real world. So this is the ratio, easy. Okay, and on the other hand, we have these ways of representing the scale, which is on the graphic form. Okay, they use the graphic form with the scale, some ruler, and they mention the number. Okay, for example, in your slide, they put it a graphic and they mention this from this line to this line and to this line. Okay, the whole line, the long line here is a 1 kilometer. So we divide by 2, it will be a 500 meters or 0.5 kilometers. So this is another ways of representing the scale. So, but these two have their own advantage and disadvantages. Okay, so if you guys, which type of scale that you prefer? Is it using the ratio scale or using the graphic scale?
Ratio.
Juan kata ratio, Intan Kamila kata ratio. Anybody who say that graphic is better to use? Tak ada. Alright. So as I mentioned, both have their pro and con. Okay, let's see on the ratio type of scale. Okay, usually they mention in 1 to 100,000. Satu nisbah 1,000, something like that. It's a ratio scale. This type of scale easy for you to make a calculation. Okay, you measure the atas map, on the map, easy for you to do the calculation and get what is the distance on the side. Okay, on the real world. In the graphic, you need to measure on the graphic, and then you put it on the map, and you can see, oh, this distance is equivalent to 1 kilometer. All right, same goes, but a different method. This the ratio scale easy for you to do the calculation, but for comparison purposes, it's better to use the graphic scale presentation. Okay, it's easy for you to compare the distance between the scale and the distance on the map and get the distance on the real world. Okay, in ratio, you have the ratio, you measure the distance on the map, multiply with the ratio, you get the distance on the real world. Same goes. Okay, I give you one situation. For example, when before I joined UTM, become a lecturer, I have worked in engineering survey. Okay, in a survey which developed the road. Okay, in road development, they will refer to the main drawing map, main design. The design of that map being designed by the architecture, by the engineer, and then they will share the same document to the contractor, and the contractor will construct the development based on the drawing. Okay, construct the development based on the drawing. Usually the drawing being designed in a A1 size map. Okay, with the A1 size map, of course, you will have your own scale at that moment. Okay, for the user to do the measurement and to construct the development. Okay, the building. Unfortunately, the A0 size or A1 size map is hard for mobilization. Okay, letak dekat office, you put it in your office to refer, is okay. But for mobilization, you as a surveyor or you as an engineer, when you go outside to the site, it's hard to bring that A1 size map. And that is why they will provide the reduced size of map the complete drawing in the A3 size, for example. Okay, easy for us, for the workers to refer, okay, to do kind of measurement and so on. Okay, just imagine the map from the A1 size being reduced into A3 size. Okay, so at that particular moment, did the ratio scale still relevant or still can be used? The map that designed in A1 size being reduced to A3 size. Okay, mean that the scale stated on the map will be the same. One tattoo is about 1 to 10,000 will be appear same at the reduced size of map 1 to 10,000. So my question is, do we still can use the scale?
Tak boleh doktor, skill dia sepatutnya dah berubah.
Scale dia dah berubah, so we apply the ratio scale on our measurement. So, but if the scale been represented in a graphic form, okay, in a graphic form. So when we reduce the map, the graphic will reduce accordingly. Okay, so whenever you use the map that been reduced, you can still use the graphic scale. Okay, because why? Because it been reduced accordingly to the map yang besar tadi itu kepada A3 sama. Ratio yang dikecilkan itu sama. Okay, so in that case, that graphic scale still can be used, but not the ratio type of scale. So macam saya kata tadi, there's a pro and con dia. Okay, when you involve with the dunia luar, bila you dah bekerja, when you get your experience working outside, okay, then you see, okay, why they provide, sometimes those map provide both the ratio scale and the graphic scale. Okay, so when we involve the reducing or enlarging the map or the representation, the graphic scale still can be applied or be used.
Faham doktor?
Okay, so information presentation process, to make certain information can be present. Data presentation become more critical when map can be derived in any stage of the data processes. Okay, for example, previously when they produce a topographic map, we have to wait years for the map being produced. Okay, because acquiring the data, editing the data, and composing the data before we print out the data will take years in order to do that. Okay, with the old technology, of course. Okay, but nowadays, whenever you're compiling the data for topography, you have this river data. So this river data already can be used for another mapping purposes. It's not that we have to wait until it produces the last result of the data. No. So the mapping can be done or can be derived in the middle of producing a map itself. Okay. Hardware and software development also influence the ways of presenting the data. Okay, user need and expectation, user needs and expectation also changes. Okay, so macam mana perubahan dari segi expectation ni? Okay, contohnya macam saya kata tadi, I mentioned, if you are using the topographic map that were produced in 2015, where we are now in 2021, is 6 years different, we can say that this topographic map is still new. Okay, but in the development of technologies nowadays, we cannot tolerate with that kind of 6 years gap between the map being produced and we're going to use in this year. Okay, for example, kalau if we use the information from the internet, okay, from the internet we use the information and suddenly at the bottom of the page they mention that this website had last been updated in March 2021. Okay. Definitely, we see that this website is not being maintained well, okay, because already 2 months did not do anything. Okay, so we say that this information is not up to date. Okay, this is how the human expectations are changing because of different technologies and the different of device that we have. Okay, so now, because nowadays I mentioned just now, we have the data that can be present in a real time. The data can change in a real time. Why we need to use the data in the 2016? Okay, so when the technology changed, the expectation of the users also change. Okay, so the information presentation, the data presentation must take into consideration about the cartographic element, map design. As I mentioned, basic representation in map using point, line, area, or polygon, and also text. Okay, text is to label the features. This is Laut Cina Selatan. This is South China Sea. This is Sulu Sea. This is Indian Sea. This is Johor. This is Malacca. This is Negeri Sembilan. So the label text being used in order to make the users understand the data. And the combination of representation are different in each presentation. Okay, kita nak gunakan presentation yang macam mana? How we going to use the color? How we going to use other symbol? Okay, so in cartography we have this so-called as a visual variables. Okay, ataupun dalam bahasa Melayu kita panggil pemboleh ubah. Nampak kan macam pelik sangat, tapi dalam bahasa Inggeris lebih mudah, visual variables. Okay. In cartography, some visual variables can be used. For example, shape, orientation, color, texture, value, and size. Okay, we can see on your right side the shape, or we can call it as a form. Okay, usually this form being used to represent a certain features. For example, like lighthouse, the mosque, the church and the school, the factory, and so on. They use a form to represent the features. Okay, and again, as I mentioned, it's really depending on the scale. If you're using large scale, you can map the mosque in a polygon shape. But if you're using the small scale, then the shape of mosque can be used as a symbol to locate that is the mosque, and text to name that is a Masjid Sultan Ismail UTM, for example. Okay. The orientation, okay, is another variable that we can use, and color is commonly being used. Okay, for example, we have this Negeri Johor to differentiate between the district with the different district. So color should be used. Okay, blue for Johor Bahru, green for another district. Okay, without telling that which one is better or greater in the sense of quantitative data. Okay, we are talking about the qualitative data, a different type of data without comparing to each other. So color mostly being used. Okay, and size, you can see the size. Okay, for example, small, the rules of small size should represent a small value. The bigger size should represent the higher value. Okay, and this one is a value using the color. Okay, whether you can use a darker green to lighter green or darker red to lighter red. It depends on the color that you choose. But the value is different in terms of the intensity of the color. Okay, and the lighter color should represent the lower value compared to the darker color. Okay, texture is another variables. We rarely use this in the mapping, but if you look into this topography map, basically they use this texture to represent kind of vegetation area. For example, like kawasan kelapa sawit, kawasan getah. Okay, they color it in green color for vegetation area, and as the texture, they will put kind of form of the form of kelapa sawit or form of palm tree in the area. Okay, so they use the combination between color, form, and also the texture. Okay, we can see the next slide that show you how the visual variables can be used on the feature data type, which is the point, line, or polygon or area. Okay, you can see in size, a point can be used as smaller, circle or a bigger circle. I show you this example on the internet user around the world. You can see the small circle representing a small numbers of users compared to the big circle. Okay, so for line purposes, for the size example, the bigger line might be it can represent the highway plus highway. Okay, the smaller line, I mean the width of the line is less, can be represented as a state road might be, and might be at the smaller line could be represented as a road in Taman, in a housing area. Okay, so this size being used to differentiate the data that we have. Okay, and area you can see on the size is hardly can be differentiated, but still can be used, but we rarely use the size as the representing the area. Okay, so for the size as a visual variables, point and line are good to use this point for this size visual variables. Okay, for value you can see also in the same size of point with a different intensity of color. Okay, same goes to the line and polygon, and it seems like this value can be applied to point and line and also the polygon very nicely. We can see the difference, we can get the information of the differences. Okay, the grains and texture can be applied in polygon. We can see the difference easily, but hard on the line and really hard on this point form of data. And color you can see for the nominal data, okay, for the data in the qualitative type of data, is good to be representing using a different color. Okay, for example, as a point, we can see here the different color. We can say that this point can be representing a mosque, for example, for rumah ibadat, for example. Okay, blue, this green can be represent a mosque. This red can represent the tokong, for example. This orange can be represented as a quail. Might be the blue as a church. Just to tell the difference without telling which one is bigger than others. No, just to tell this is different type of data. Okay. For the road example, we can also differentiate the line with the different color. You can see another example after this. And definitely for polygon or for area form of data, it's good to use this color as the visual variables. Orientation also for area, hard for the point and easily hard to use on this line symbol, but for the shape, it can be applied to all of these symbol, point, line, and also area. Okay, for example, shape of mosque, shape of tokong, shape of quail, shape of kubur Muslim or kubur tanah perkuburan Christian, we can easily apply the shape for that particular data. Okay, and also the shape of line. Okay, you always see this in the different type of boundaries. Okay, international boundaries, state boundaries, district boundaries. Okay, they're using a different shape of line. Either is line dot line or line dot line, or might be a straight line, or might be the line with star, with the line with the star. So these are different shape of line that we can apply to differentiate the line type. Okay, and it also can be applied in an area of polygon form. Okay, depending on the data that you represent. Okay, type of mapping. Answering the question where, how, what, and where, okay, concerning what map type and which map skill to use in digital map environment, do skill play the main role, okay? So nowadays, we are working our map in a digital environment. Of course, I introduce you the map in analog, but toward the end, we are working the map in a digital environment. So my question is, do skill play the main role in digital environment? We have capability to zoom in and zoom out, okay? Which we know that when we zoom in, the scale will be different whenever we do the zoom out. So my question is, in digital map environment do scale play the main role? Oh, semua senyap ni. Ya benar. Okay, so tak ada soalan. Okay, saya tak ada jawapan. So prepare yourself. Might be this will be your one of your exam question. Okay, so I ask you guys, you didn't respond. So might be, okay, I just say might be. I just kind of through to you. It might become as your exam question. Okay. So as a type of mapping, I go fast with this one, this cadastral map. As you know, as a cadastral map, you guys are quite familiar with that. But for the first year, cadastral map is referring to the land parcel as the basic geographic unit to register land ownership. Okay, I share you just now the cadastral map. And this map usually been produced for managing the land, okay, land administration. But at the end, government would like to get some tax from it. Okay, so that's why they come out with this ownership for the piece of land, because our government needs some money to rules to admins the government. So tax is one of our resources. Okay, usually this cadastral map being used as a large scale map, 1 to 1,000, 1 to 200, 2,000, and this map being derived from this accurate survey in a first class survey. Okay, tahun 2, tahun 3, might familiar with this first class survey, but in first year, then why you need to do a precise survey? Because of this is referring to the ownership. Okay, 1, 2 cm, 10 cm berbeza, different, will make chaos and will make the people fight to each other. So that's why on this cadastre, they are looking for the high accurate survey in the first class survey. Okay. The other maps, such as the utility mapping, to map all this utility line, the gas line, the water line, sewerage, electricity. Previously, the electricity all been mounted on overhead cable with the post and so on. But nowadays, all the utility been embedded under the ground. Okay. Good for I looking, because it's more clean view without the cable, but we need to store the information of where is the cable, because underground we cannot see. So that's why the JUPEM come out with the GPR, ground penetration radar, to detect all this utility, and they do the utility mapping. Okay. Used to keep the accurate and up-to-date record of their infrastructure for maintenance and planning purposes. Okay, because when I myself involved with the construction just now, last 10 years before I joined UTM, okay, I faced one issues where we do the digging to construct the road. We did ask the SAJ to tell us where is the pipe running at the site. They just bring me an A0 size map with the highlighted color, and okay, this pipe is here, and here. Okay, and suddenly when we do kind of excavation, we did broke the pipe, one of the main pipe, and the water burst up to 10 stories of buildings. Okay, because why? They don't have this kind of accurate data for the utility mapping. Okay, socio-economic mapping derived from the statistic related, such as demography, the census data. This is more on the socio-economic, and environmental map is more on vegetation, soil, hydrology. Okay, this is more on the thematic mapping that based on a certain theme or certain phenomena that they want to represent or to model. Okay, for example of cadastral map, we can, as mentioned, they have been used as the point, line, and polygon to store the data. Okay, and utility mapping using a different color to represent a different type of material that they use. Okay, The green color show that the pipeline already been maintained and they use a new product or new pipe material. And the red color might be the pipe that need to be maintained as soon as possible because it might be burst out. And the blue color and yellow color might be a different type of pipe that they use for the utility. Okay, this is how they can do the mapping using the different visual variables as a color for this differentiated pipe. Okay, as I mentioned just now, okay, you're using the size as the representation to show the differences of the number of the internet users. Okay, this map have been shown you at the early stage of the class. Okay, the biggest circle shows you the biggest internet user number in United States, but in the European you can see that small circle, but it congested to each other. It dense in the area of the European country. So we can say that in European country, they also have a plenty of internet user, but it's been separated between the countries. Of course, in United States, the biggest country, the biggest is basically Russia. The United States is a big country, so they only use one symbol for entire United States. Okay, and beside we can see at the Asia parts, small part in Singapore, Brunei, Thailand, and also Japan, China, and Australia. So they use the visual variable of size to differentiate the number of users for each countries. Okay, another variables that they use is color to show you differentiate of wind speed, but somehow I did not agree with this representation. Because the color did not show you how it changed from a certain speed to a certain speed. Okay, the color is different to each other. It's hard for us to understand this data. Okay, so traditionally map can be divided into two, which are the topographic map and also the thematic map. Okay, topographic map is a map that shows the relationship of the features on the real world. Okay, topographic, topo means relationship, graphic is a graphically, so the topographic map representing the relationship of the features graphically. Okay, if you locate the UTM Skudai and you locate where is Johor Bahru, you can say that UTM Skudai is located on the north part of Johor Bahru, where the distance is about 20 kilometers from the city center, in the nearby to Skudai and so on. So that is how the map tell you the relationship between the features. Okay, the Sungai Skudai is running not running in the UTM land area, for example. Okay, that is the relationship that it shows from the topographic map. So that's why they call it as a topographic map. Topo mean relationship, graphic mean graphically. Okay, so a lot of other things been shown in the topographic map, such as the road, river, building, land cover, height, and so on. Okay, and on the other hand, for the thematic mapping, is depend on the theme that they want to represent. Okay, if they want to represent the themes of COVID-19, of course the data will be related to COVID-19 and have some references to the topographic or geographical features. Okay, so example of topographic map, they have used a certain standard. Okay, red for developing area, for example, blue for water bodies, green for vegetation area, park or forest. Okay, the line in red might be the road network. Okay, this is a basic representation of topographic map. But when you look at this real topographic map, which is the Skudai area, we can see that they're following a certain standard, and a lot of things been put into this topographic map. You can see the black dotted is the building, okay, and the red line is the road network, and also you can see the river network. You can see the water bodies. Even you can see the contour line on the map representing the height information, okay, and other features, okay, and also the not to forget the text that they use in order to label the features. This is the example of topographic map. Okay, and
Doktor,
Balkis.
yang tadi tu kan ada grid kan. Kalau grid tu dah ada specific measurement ke?
Okay, for the grid, okay, basically the grid is a part of the map element. Okay, yang mana it's good if we can apply or we can insert the grid. The grid size is depending on your decision. Okay, it's not appropriate if we use a very dense grid because it will disturb the visualization on the map. Okay, and usually we can see the grid being used a very light color. The grid is there, but it will not attract the attention of the user. Okay, the size is depending on the size of the area of your mapping itself. Okay, for topography map, they have this kind of standard. Okay, usually they have every 10 meters or every 100 meters, for example, they will have their own grid size. Okay, Balkis?
Okay, thank you, Doktor.
Welcome. Okay, so now about the thematic mapping, as I mentioned, is depending on the theme. For example, this simple sample of thematic map will show you the population density. Okay, population density. So from the figures, you can find out from the legend, the darker color will bring you the greater value, is bigger than 50,000, and the lighter color bring you less than 5,000. And from the map, you can see where is the part of most the people who stay there. Okay, but the density is more toward the southern part of that particular area, and some part in the middle. Okay, so we can say that might be the city center is located at the south part of this area because that is where the population is dense. Okay, so the thematic mapping, the definition map that can contain and present qualitative or quantitative information. Apa itu qualitative, apa itu quantitative? Okay, and it's an information of certain application and discipline that are related to the topographic features. Usually, topography map will be base map. Okay, usually we are using the topography map as a base map, but that happened in last decades. Okay, for nowadays, because of the rapid development on the hardware and software, able us to manage huge amount of data, and nowadays you can see that they are using the cadastral map as the base map. Because why? It gives you more accurate data because they're using of the large scale map and using the high accuracy survey map. Okay. And the base map, any map that contain topography where information set. Okay, usually the base map we're referring to the geographic information. Okay, so it's a new if you compare to topography map. Okay, topography map been used before, and nowadays we are talking about thematic mapping when the users of this map is no longer only from the mapping people, but also from the other discipline. Okay, so this map oftenly being used currently. Okay, the concept of thematic mapping. Okay, I think I'm not going to touch on this because it seems like the time is running out, and I think it's better for me to stop here at the topographic and thematic mapping. Then later we're going to continue with the cartographic data analysis. Okay, so for the next test one on Sunday, we will cover up to the topographic and thematic mapping from the first class until that area. Okay, any other question before I end this class?
No, Doktor.
Sampai thematic mapping ke?
Sorry?
Sampai thematic mapping ni?
Ya, sampai thematic mapping daripada yang first sampai ke mapping. Okay, so please take your attendance. Session 1, session 2.
Doktor, test nanti subjektif ke, bulat-bulat ke? Macam mana doktor?
Semua subjektif lah, ini essay form.
I see, okay. Baik.
Okay, so kalau tak ada apa-apa soalan, I think we can call the day off for today. Okay, thank you very much for your attention. Please take your attendance. Okay, saya akan biarkan sampai pukul 5.45 before I will deactivate the QR code. Okay. So guys, terima kasih banyak-banyak. Again, take care of yourself. Please be safe. Okay, tak payah keluar sekiranya tidak perlu. Okay, kita tak nak wabak ni terus mengganggu kita punya perjalanan. Alright, so ada apa lagi?
No, doktor.
Okay.
No, doktor.
Okay, terima kasih banyak. So kalau tak ada apa-apa, saya ucapkan ribuan terima kasih dan Assalamualaikum warahmatullahi taala wabarakatuh.
Terima kasih doktor.